Hi, it's Jan Beta, and in the last video I repaired this ZX Spectrum Plus 2 that had some RAM issues I was able to fix. It is still in pretty rough visual condition, so I'm going to have to do some restoration work on the case itself. And I'm also going to have a look at the transistor issues I mentioned on the board. I also plan on making a proper RGB video cable because frankly the quality that I get from the composite out is not that great, as you can probably see in the background here. So yeah, that's the plan for today. Hope you enjoy. This is just the empty shell with the tape part in there. I'm going to have a look at this later. In the first part of the video I'm going to focus on the issues that these board revisions have, and as you can see I still have my awl, actually is what it's called, not ale as I said in the last video. I'm sorry about that, I mispronounced that. This is just a pokey thing that I've stuck into the DIN socket here to get a composite out from this. I'm going to have a look at the issues with the transistors being placed in the wrong direction in these boards, and I'm also going to make a proper video cable at first, and then I'm going to focus on refurbishing the case a bit. So this is an issue 3 board revision, and these were actually always produced by Amstrad. I got that a bit wrong in the last video. I'm not an expert on Sinclair stuff. Amstrad took over Sinclair previous to these machines being produced. This board is based on the Toast Rack, which was the last true Sinclair machine, the Toast Rack 128K Spectrum, and that's probably why I misread that somewhere. These were, it seems there are no Sinclair produced boards for the Plus 2 Spectrums, and yeah, the case clearly looks Amstrad-y as well, so yeah, sorry for that mistake. I'm a bit of a Sinclair Amstrad noob. Let me take a couple of seconds to thank the sponsor for this video, Keysight. Some of you already wondered about my new fancy scope that you can see in the background here. Let me explain. I actually made a little gear for promotion deal with Keysight recently, so I got some gear from them, and in return I'm going to do some promotion for their upcoming event. So Keysight have the Keysight University Live event coming up. Keysight University Live is an online event with test gear tips and tricks, interviews with industry experts, and more than 100 test gear prizes worth more than 300,000 US dollars. So you can sign up now for an early bird entry and tune into the webpage or the Keysight Labs YouTube channel, which I'm going to link in the corner, for the live event kickoff. Check out the event if you like. I highly recommend doing so. I actually know some people who won prizes in past similar events, so the chances are not that slim actually. You can sign up by clicking the link in the video description and you are going to be in for the event. Thanks Keysight for organizing this event and giving away so much stuff, and thanks for the scope, obviously. There's going to be a more detailed video about the scope and the event soon on this channel, so stay tuned. And now back to the specky. So the transistor issue with these board revisions, there is an issue 1 of these boards that doesn't have the problems I'm going to point out now. These issue 3 boards have several transistors in the wrong direction, so they just turned them around accidentally. The silkscreen actually has the transistors reversed. There are several possible explanations for why this happened. Maybe they planned on using different transistors, maybe they just got the silkscreen wrong, I don't know. The fact is that there are 3 3904 transistors on here that are reversed, which for some of them works. There's one that's responsible for generating the composite signal, and that actually screws up the composite signal. That might be the reason why I didn't get a proper composite signal out of tapping into the RF modulator can here. And I actually tried to do my 1-wire composite mod on this that I've done on 48K Spectrums previously, and that worked on those machines. Usually you would have the signal coming in here, and I just wired up the signal on the board to the middle pin on this RCA jack and disconnected the circuitry from the RF modulator completely. It didn't work. I got a messed up picture output from that. So the transistor that is actually located here could be the reason for that. And I'm just going to turn around all the transistors on this board. There are several good sources detailing the problem across the internet. And the best one I found is this PDF by Byte Delight that I'm going to link in the video description as well, detailing what the problem is. And actually TR4, TR5 and TR7 are 2N3904 transistors that are all mounted incorrectly in these board revisions. So these have the emitter and collector pins reversed. The base pin is the center pin. So yeah, basically on this particular one, the 12 volt supply that is supposed to go into the collector goes into the emitter pin, which of course makes no sense if you know what transistors are supposed to do. That's not how it's supposed to work. That might be the reason why I got a messed up composite signal. So the transistors in question are TR4, which is located here. We have TR7, which is located over here. And we also have TR5, which is located next to the reset button here. So these are the 2N3904 transistors that are all in there reversed. So I'm just going to take these out. And I think I'm just going to put new transistors in because I have a lot of stock of those anyway. And I don't know if these got damaged during the life of this machine because they had voltages going to the wrong pins. So I'm just going to play it safe. These are very, very standard parts. In fact, they are the most standard NPN transistors you can find, I guess. I'm just going to put new ones in the correct positions. So I have these reversed now and the new ones in. And as you can see here, they're going against what is indicated by the silk screen. So the round part of it is facing away from the round part on the silk screen. But this should be actually the correct orientation for these. So yeah, did that for the 3 transistors I mentioned. I want to briefly check if this board now gives me a proper composite signal on the RCA jack as I indicated previously. So I just hooked up an RCA composite cable directly and it's still messed up. So I don't know, maybe the composite mod doesn't work on this version of the Spectrum. A bit odd. I was hoping that this would fix the issue, but it still works actually, so that's a good sign at least. I just inquired about the one-wire composite mod that I did here, and it seems that the circuitry in the newer Spectrum models is not quite the same as for the 48K Spectrums, so this mod doesn't work because there's not a proper composite signal getting here. So yeah, this doesn't work on these. So as you can see, the picture quality is still pretty messy. So the next thing I'm going to do is to replace the electrolytic capacitors on the board, which is something I regularly do with these older computer systems. And I know there's quite a bit of discussion going on about this, but for me, it's pretty much out of the question that these capacitors that were produced in the 80s are not going to last much longer. And they usually use pretty cheap brands for these machines, sadly. So they are very likely to be out of spec already or to go out of specifications pretty soon. So what I usually do is to desolder all the electrolytic capacitors one by one to not get the values mixed up and replace them with the same capacitance ones and the same voltages or slightly higher voltages. You don't want to go much higher voltages because the specifications of the caps change a bit with higher voltages. I usually use Panasonic caps to replace these. There are several known good brands that you can use. I don't recommend using cheap brands because if you want to do something like this, why not do it properly? So Yeah, the next step is going to be replacing all the capacitors, recapping the whole board. Usually that also significantly improves the picture output quality. At least the 48K ones I worked on, it did some magic and gave me a clearer picture on the composite out. That's going to be the next step. Let's recap and go soldering montage. Yeah, sometimes they can be a bit stubborn to get out. If that happens, I usually just add a bit of fresh solder and then desolder them. That usually makes things significantly easier. I think the polarity markings on the board are correct on this board, but you always want to be on the lookout for things that went wrong with the silk screen. That happens. Yeah, that concludes recapping the whole board. I didn't have good brand capacitors for some of the 1 microfarad ones, I'm afraid, but they are still quite good. 105 degrees Celsius rated Jamicon. Not the best capacitors around, but I didn't have any Panasonics for those. But yeah, we're going to be fine probably. Let's do a quick test and see if this still works at all. Yay, and it still powers up, which is of course a good sign. I think the picture got a tiny bit better, but it's still because, yeah, my connection here is not very proper. It's still pretty bad. So the next step is going to be to build a proper RGB cable for this. So in terms of making a new cable, I found that Ian Priddy, who runs the Retro Computer Shack, which I highly recommend buying cables from because they are excellent quality, sells them in his eBay store. I'm going to link that in the description. And he also has his cable designs, or some of his cable designs at least, openly available. I figured, as the cables are very highly regarded by many people, I'm just going to go with his design. And as you can see, I'm going to leave out the composite portion of the cable because I won't need that. I'm just going to build the RGB portion, and we need 150 ohms resistors and some diodes. This is the bright out signal, which is connected to the RGB signal across some diodes. For some reason, I'm not quite sure. I'm not an expert on video, but yeah, this seems to be the way to do it. And the audio signal I'm also going to leave out because I'm going to take the audio signal. In my setup, I'm always going to take the audio signal directly from the 3.5mm mono jack on the back of the machine and put it into my sound hardware, because I rarely use the monitors I have as a sound source. So we need the RGB and the C-Sync signal, and this needs a 180 ohms resistor. Yeah, so this is the design I'm going to go with, and I have all my components here. I have a SCART plug. I have some diodes, 180 ohm resistors, 150 ohm resistors. The other side of the cable is going to be this DIN plug. This is an 8-pin round DIN connector, so 180 degrees DIN connector. There's also the ones that have like the horseshoe form factor, but this is the round version that fits in the spectrum. And for the cable, as we need 1, 2, 3, 4, 5 strands of cable, I'm just going to use, or try to use, an old VGA cable because I have plenty of VGA cables and very few VGA monitors that I'm using. So I'm just going to cut up one of these and try if that works for this purpose. So the first thing actually is going to be building the SCART portion of this. And Ian has very nice photographs of how he arranged his stuff in the SCART connector. There's a bit of room in these casings, so you can have some components in there, but not that much room, so it's really helpful to have this. And I'm just going to go by his plan. So and then we need 3 diodes over this, and I'm going to bend one leg over the other diodes. So yeah, that's going to be fun. So now it's time to cut up the RGB cable, the VGA cable, and see if we actually get reasonable. Yeah, that actually doesn't look too bad. So there's a foil screen, and then we have this wire mesh screen as well, which we are going to use as the ground. Okay, so this is a better cable than you would need. I think you need a screened cable. Yeah, it turns out using a VGA cable for this was probably not the brightest idea because we have a lot of very small cables. I have RGB red, green, blue here. They were individually screened, and actually beneath this foil there is another copper wire that's providing shielding. So yeah, it was a bit difficult, let's say. Yeah, I did quite some things off camera again because I was at the end of my rope, so to say. The cable I made after these schematics from Retro Computer Shack with the VGA cable didn't work out for some reason. I guess it's my inability to solder, and I made some connection to some ground where it wasn't supposed to be. I just don't know, frankly. However, I made another cable, not using a VGA cable this time, and that works better. As you can see, I just used an unshielded 6-wire cable I found in my parts bin, and that seems to give me a very clean picture, so I'm not too worried about the shielding actually. Don't know how well it translates through the camera, but the picture quality is very crisp, so that's a cable that works for me. It turns out, though, all the fancy diode wiring is not really necessary for the Plus 2. I found another site that has instructions for the cables, and yeah, I basically did what is laid out here. The 150 ohms resistors for red, green and blue I put in there, and then I connected a shield. That's just one wire. It's not a shield, it's not a shielded cable, so I just connected one wire to shield, which goes on the ground pin that is shown here, where it says screen, pin 17. And I also connected the CVBS signal, so the composite signal. I left out the capacitor here completely, so that seems to work fine. We should also have a composite signal on the SCART now. Yeah, and that's basically what I did. I connected the C-Sync signal with the 180 ohms, so I made a mix of the two designs. I connected C-Sync according to this schematic. I connected only pin 16 on the SCART to the CVBS signal. I connected pin 17 to ground screen, and I connected the red, green and blue wires according to this, which is actually the side. This view is from the side you solder. So yeah, that's good to know. It just says here solder connections side. That's what I did, and it works. So I'm pretty glad. I was really losing my nerves. I'm sorry I didn't film the second build, but this one seems to work now. Yay! Now the only thing left to do is to actually finish the connectors and close them. Just left them openly tangling in the breeze here. So I'm going to do that, and then I'm going to have a proper SCART cable for my +2. That's pretty cool. Yeah, and it's literally just a 6-stranded, quite thin cable, but it works fine. I didn't make it too long, so it doesn't pick up a lot of interference, I guess. Yeah, and I'm going to put some electrical tape around this so the strain relief can actually grab. I left out the whole diode construction because it's not needed. Yeah, these DIN connectors I got are pretty crappy. They don't even fit the sleeve doesn't fit the connector correctly, so it has a lot of play. But it's going to do for now. Yeah, the next step is going to be to put proper heat sinks on here. I'm going to put one on the Z80 processor actually, because these tend to run rather hot. The one on the ULA, I think I'm just going to put some new thermal compound on there. Although it's not the best thing, it's just a bent aluminum thing, but it's going to do. Let's take the heatsink off here, and I think we have to bend some tabs here to actually get it off. Oh, we don't even have to bend them that much. We can slide it in. So here's a nice glory shot for all the Amstrad aficionados. It says Amstrad. Just clean this all off and putting new thermal compound on there for this to make good contact with the chip. Don't want to bend this too much because it's aluminum and it's going to break if you bend it too much. Okay, there we go. Worst case, we're going to put a proper heatsink on there. Just cleaning up the CPU with some isopropanol as well. And I'm putting some thermal adhesive on there. Heatsink plaster. Ordered this for very inexpensively from eBay some time ago. But it seems to work fine. I used it in a number of machines now and it's solid. Using some of my heatsinks for 40-pin chips. They're just aluminum, but rather good quality. So placing it as straightly as possible on the chip. And then we're going to let this cure. And while the thermal adhesive settles, let's just have a look at the case and remove all the parts that don't like to go into the water. I think the bottom half we can just completely submerge in soapy water, which is what I'm going to do. For the top half, we're going to have to remove the keyboard and the tape. I think I'm going to start with the keyboard. Oh, and we have broken off posts there. Okay, should come out. Oh, that's pretty neat assembly actually. Looks kind of tiny. And there's one broken off screw post here that we're going to glue back on, I guess. And we're going to remove the tape. Okay, the motor has one screw here. And I think these are holding the main assembly in. Now it feels like we're getting somewhere. Okay. Okay, I think I'm actually going to leave this screw with the little spring load. This is the spring load mechanism for the flap here. I'm going to take this one out. I think we should also be able to remove the clear plastic. Oh no. Okay. So I think this whole part and this part and the bottom half of the case can just go into some soapy water for a while and soak. And I think I also want to take all the keycaps off. There's some undefined dirt in there. Hope they just come off with the keycap puller. Let's see. So these keycaps have a little spring in the center of the actual keycap, and that actuates the keyboard membrane and closes the contact there. So these are, I don't particularly like these, but I think I'm just going to put them in some water still. And these springs, I'm going to put in a separate container. Yeah, these are dirty. These definitely need a wash. Oh, these have little retainers there as well. So there's a little wire that we have to reinsert into the key, I guess. That's going to be fun. But you gotta do what you gotta do. Oh, and we lost a keyboard post there. That's pretty bad. I'm as careful as I can. But the plastic seems to be massively brittle, so one of these broke out of the plastic here. Hope we can glue that back. Okay, these go into some water now. Yeah, so this little part broke off from here, but I think we might be able to glue it back in somehow. Probably going to use some of my plastic glue, and that's going to be an easy fix that way, probably. I think I also want to take this whole black part off. It should be clipped in from the bottom here. Yeah, I think it might just be clipped in. Yeah, the screws. The screws, we have to remove these screws as well. Okay. I think it wants to come out. I'm trying to be really careful with this because the plastic seems to be really brittle. So and this is also really bent pretty badly, actually. There we go. Okay, this part is pretty badly bent. I don't know if you can see that, but that's going to be an easy fix. It's already better. Wow, this is thin metal. It's not very sturdy at all. No wonder this bends. Okay, we're going to straighten this out properly. Yeah, and this is the membrane, which, judging by the fact that it works, seems to be all right. So, oh, there's multiple layers here. And there's a lot of dust on here. Okay. And there's also a lot of dust in there. Okay, so I think what I want to do is to put this whole thing into soapy water. I'm going to remove these little retainers, clips, though, before I do that. And yeah, I think this just has to be dusted off, I guess. Usually these flat flex cables get really brittle and the contacts delaminate and things like that. But this is probably made by Amstrad already, so maybe they had better keyboard membranes than Sinclair, at least. So yeah, this goes into soapy water now. So I put the lid from the RF modulator into some vinegar, and I'm just going to let this sit overnight in the hopes that the rust is going to go away, and maybe the sticker is not going to go away. We're going to see. Yeah, as you can see, the case turned out way better than it was before. I'm still going to go over this with some window cleaner and microfiber cloth to get some of the spots I didn't get. Yeah, but quite satisfied. There were all the stains that were on here are gone, and yeah, the back is pretty scratched. There's not much I can do about that. The serial number sticker held up, even though it was underwater for a while. But yeah, pretty satisfied with how this turned out so far. So here's where the screw post came off, and fortunately I have the broken off piece. So I'm going to try to position it correctly. Yeah, like this. And I'm going to use my plastic glue that I used to put together a completely crumbled joystick before, so pretty confident that this is going to work. And then just let it sit. And I'm just going to use the same glue on this broken off keyboard part here. This stuff forms a weld bond between the plastic pieces, and so it should be as sturdy or not so sturdy as it was. Okay, so I'm going to let the glue set. While the glue does its thing, I'm just going to take a look at this cassette assembly. I'm going to brush off some of the dust on here, clean the erase head and the read-write head, and yeah, probably put some lubricant on here as well. I think I want to also replace the electrolytic capacitors on here, because why not while we're in here. Okay, so this looks better than from factory now. There was a lot of soda residue and some unknown gunk on there. For cleaning the heads, I'm just using isopropanol alcohol and a Q-tip. And I'm going to put some silicone grease on all the moving parts. Otherwise, it seems pretty good. I'm also cleaning the capstan, because that's a good idea. You don't want to get too much alcohol on the pinch roller. There's special chemicals for making this grip better again. Sometimes you can use a bit of very fine grit sandpaper to make them work again. But this one doesn't feel too bad. It's actually still pretty elastic, it seems. So I don't suspect any issues there. Maybe we are going to have to replace this belt. It's pretty loose. It still moves the wheels if you turn the motor. But yeah, this other one seems to be fine. That has more elasticity to it. Elasticity? Is that a word? I don't know. But this one, it's pretty loose. Usually they are looser than you might expect, but this one, it feels dry as well, so it's not very elastic still. We're going to see. So I think after letting this glue settle for some hours, you should probably wait overnight and things like that. I didn't do that, but it should be sturdy enough to reassemble. So yeah, that's what I'm going to try. And I'll of course start with the worst part, allegedly, the keyboard. Not quite sure how we're going to go about this. We have to put the retaining things in from the back side, I think. Yeah, I think through here you have to put the keys. Yeah, that's gonna be fun. Let's try with the spacebar at first. So, taking the spacebar here. Was this supposed to go like this? Yeah, there's a little indentation there. Like so. There we go. Okay, now we can put this in here. Yes, I think that's the way to go. So you have to fully disassemble this probably to get these back in a reasonable way. I have been warned about this keyboard actually. So this is not really a surprise. There we go. Yeah. You have to fully get it out of the clips here and then just hold the key down and slide it into these clips and into the other clips and then you're good. Okay. There are several different sizes of these, I don't really know what to call these, retaining spring things, wires, I don't know. These ones are for the caps shift keys. The longest one is for the spacebar. They only fit the keys they belong to, I guess, so it's not going to be a big problem. Just wanted to point that out. And remember that the spring on the spacebar is the one that's different from all the others. Yeah, I'm just going to put all the other ones in and go by the picture I have on my computer here. So the brake key goes here. So apart from me misplacing the caps lock key at first, I also confused the springs. This smaller diameter spring goes under the enter key actually, and the other springs are all the same except for the spacebar. Nearly finished, nearly there. So now to put these shenanigans back together. This is clearly where the spacebar goes, and I think this should line up with this like so. This should just go on top, technically. Looks good to me, actually. Okay, which brings me to this next part here. Straighten this whole metal assembly out a bit, actually, so hopefully. Oh, these 4 screws are for these. Yeah, okay. I remember now. These are for pushing down on the ribbon cables. Okay, probably this bottom side should go in first. There we go. Back in. Doesn't look too bad. It's actually pretty scratched, but that's okay. It looks better than before. And now the PCB goes back into the bottom case. This lives in here. And these are the very short screws. Which makes sense because there's not a lot of room. I forgot to clean the expansion port. Actually, I'm going to do that now. I think I can still get in there. Yeah, these are pretty dull. I'm going to put some contact cleaner on there. Unfortunately, we didn't lose any of the rust, although it was sitting in vinegar all night. Yeah, I guess you could scrub it off. Kind of want to leave the sticker on there, but it's already a bit, yeah, it's pretty destroyed. This is how it's supposed to look. Yeah. At least the rust, some of it somewhat came off, but it's still, of course, very corroded, because rust is corrosion. Yeah, it's not rusted anymore. I guess I'll peel the sticker off fully and I'll put it back on there. And then kind of close it like the hood on a car or something like that. Hey, and it still powers on fine. And we still get a somewhat crisp picture. It has some, maybe you can see it on camera, some interference lines going in there. Probably because the cable doesn't have any proper shielding. You should use a shielded cable, of course, for things like this. But yeah, I got away with this one. For now, I'm probably going to buy a proper one at some point. Now, for testing the Datacorder, I have this Spectrum Plus 2 version of Mario Brothers, Nintendo's Mario Brothers, made by Ocean for this machine. And this is actually made for the Plus 2, it seems. So let's try if this actually works. Push this in here. Okay. Press the Enter key and the tape and press play. Okay, and it somewhat plays. I don't know if it's the correct speed. No. It's stuck, so we need a new belt. We need a new belt. Yeah, it's somewhat, it seems to want to work. I just temporarily hooked up my little JBL portable speaker to the output there. And it's doing something. I don't know if the tape is running at the correct speed, but it seems to somewhat work at least. The speed looks kind of correct to me too. The tape was just a bit stuck. Maybe this even works, I don't know. Yeah, the tape played to the end and we basically didn't get anything. But we got a lot of tape loading noise. So I suppose, yeah, we probably need a new belt for the tape. But I'm going to have to order one because it's pretty fiddly to get the correct one in diameter and also the thickness of the belt itself and the correct shape. There's several different varieties of rubber belts for these things, and I'm going to have to investigate that a bit further. But at least it's not completely broken, so it runs and we get a sound output from the tape. So that's very promising. I feel like I'm going to be able to fix this. So yeah, the tape didn't quite work, but that was to be expected. I'm going to install a new belt as soon as I get my hands on one, but I think that should be an easy thing to do because you can quite easily get in there from the back side. As for the rubber block thing, that actually sits in the case, and I reached out on Twitter, and actually Brandon Alford posted some pictures where it goes, and it goes exactly here. There's a little indentation in the case even, so yeah, that's where it's glued on. And it's actually to hold the heatsink, which is otherwise just loosely flapping around in there in place. So here's where it goes. You can see the little indentation there where the rubber block is supposed to go, and that's where I'm going to glue it. So now, of course, I'm going to have to wait a bit until this glue settles. It's a waiting game. There's the last screw. Yay! And we're done. Whoa, that was fun. That took way longer than I anticipated. But the results speak for themselves. I'm pretty pleased. I think that concludes this video. I'm quite satisfied with the outcome actually. It looks way better than before, and it works flawlessly, it seems. I'm currently running the soak test on the RAM again, and did some different tests and played some games, and everything seems to work fine. I have yet to get the Datacorder to work, but that's probably down to the belts being worn out, as I pointed out earlier. Maybe there's going to be another little video about that, but probably not, because it's not that interesting. If I find anything interesting, I'm surely going to make another video. Yeah, I'm now ready to enjoy this Spectrum. Hope you enjoyed this video, and I hope to see you again on this channel. Special thanks go out to all my supporters on Patreon and on the channel memberships page, and to all the subscribers. I'm Jan Beta, thanks for watching, see you next time, bye!